Picture Earth 252 million years ago, teetering on the edge of annihilation. The world as we know it was about to face a crisis so profound, it would reshape the very fabric of life on our planet. Imagine a time when strange creatures roamed vast, unfamiliar continents, and the air itself seemed heavy with foreboding. This was the end Permian, the stage for the greatest mass extinction in history, the Great Dying. It was a cataclysm that wiped out nearly all life, leaving behind a world eerily silent and empty, its ancient ecosystems shattered beyond recognition. 96% of marine species and over 70% of land life vanished. Oceans that once teemed with bizarre fish and ancient corals became graveyards. Forests and plains emptied, their inhabitants lost to time. The culprit? Colossal volcanic eruptions in Siberia, known as the Siberian Traps, unleashed a torrent of greenhouse gases. These eruptions lasted for hundreds of thousands of years, spewing ash and toxic gases into the atmosphere, transforming the climate in ways the world had never seen. Temperatures soared, oceans turned acidic, and oxygen levels plummeted. Ecosystems unraveled worldwide. The very chemistry of the planet changed, making survival nearly impossible for most forms of life. For decades, the Karoo Basin in South Africa was our main window into this apocalypse, revealing a fossil record of devastation and recovery. Here, layer upon layer of rock tells the story of extinction and the slow, painful return of life. But the Karoo is just one piece of a global puzzle. The story of the Great Dying stretches across continents, hidden in rocks and fossils scattered around the world. To truly understand the extinction's reach, scientists needed evidence from across Pangea. Only by piecing together clues from distant lands could they hope to reconstruct the full scale of this ancient disaster. Enter Tanzania and Zambia, new fossil hotspots that are rewriting the story. These sites, long overlooked, are now yielding extraordinary finds that challenge what we thought we knew. These sites reveal not just more fossils, but a different picture of survival and recovery. They show us that life's comeback was more complex, and perhaps more hopeful, than we ever imagined. The discoveries challenge old assumptions and show how life, against all odds, found ways to bounce back. Each fossil is a clue, a testament to resilience in the face of unimaginable adversity. They're helping us grasp the resilience of life itself. These ancient survivors paved the way for the world we know today, reminding us that even in the darkest times, hope can take root. Our adventure begins in these fossil-rich African landscapes. Here, the stones whisper secrets of extinction, survival, and the dawn of new life. What secrets do they hold about the world's greatest cliffhanger? Join us as we journey into the past to uncover the mysteries of Earth's most dramatic turning point. Deep in Tanzania's Ruhuhu Basin and Zambia's Luangwa and Mid-Zambezi basins, paleontologists are unearthing a lost world. These regions, once overlooked, are now time capsules brimming with fossils. Unlike the Karoo, these basins offer a continuous timeline, before, during, and after the Great Dying. The work is grueling, but every fossil is a vital clue. Here, scientists have found unique communities, new plant eaters, saber-toothed predators, and bizarre amphibians. These discoveries reveal that life on Pangea was far more diverse than we imagined. By comparing these sites to the Karoo, researchers are piecing together a continent-wide picture of extinction and survival. Did the collapse happen everywhere at once? Did some regions fare better? The fossils from Tanzania and Zambia are finally helping answer these questions. Each discovery brings us closer to understanding how life endured the planet's darkest hour. Among the most fascinating fossils in these new sites are the dicynodonts, tough, tusked herbivores and distant relatives of mammals. Imagine a pig-turtle hybrid with a beak and prominent tusks, built for survival. Tanzania and Zambia have revealed new species of these resilient plant eaters. Dicynodonts were among the few to survive the Great Dying, though only the hardiest made it through. Some adapted by burrowing, escaping extreme surface conditions. This survival strategy may explain their resilience. The fossils show how dicynodonts evolved, shrank in size, and adapted to a harsh new world. Their story is one of endurance, life clinging on when all seemed lost. Dicynodonts are a testament to survival against impossible odds. No Permian ecosystem was complete without its apex predators, the Gorgonopsians. These saber-toothed hunters with massive skulls and deadly fangs ruled the land before the extinction. Fossils from Tanzania and Zambia reveal unique Gorgonopsian species, different from those in the Karoo. Their diversity signals a thriving ecosystem, until the Great Dying struck. Unlike dicynodonts, gorgonopsians vanished completely. Their sudden disappearance marks the brutality of the extinction event. These fossils offer a snapshot of a lost world, just before it collapsed. By comparing predator communities across regions, scientists see how ecosystems unraveled. The fall of the gorgonopsians paved the way for new predators in a changed world. The rivers and swamps of Permian Africa teemed with temnospondyls, strange, often giant amphibians. Some were small and salamander-like, others were crocodile-sized ambush predators. Fossils from Tanzania and Zambia reveal a rich diversity of these creatures, indicating healthy freshwater ecosystems before the extinction. The Great Dying hit them hard. Acid rain and heat devastated their watery homes. Most vanished, but a few adaptable species survived, evolving to cope with the new world. These fossils help us track how extinction played out in freshwater environments. By comparing amphibian communities across regions, scientists uncover the geographic pattern of collapse and survival. The story of temnospondyls adds another layer to our understanding of the crisis. For decades, the Karoo Basin in South Africa has been the cornerstone of our understanding of the Great Dying, the most catastrophic mass extinction in Earth's history. Its vast fossil beds have provided a window into a world in crisis, and for a long time the Karoo story was thought to represent the entire planet. The fossils here told a tale of devastation and a painfully slow recovery, with the sturdy dicynodont Lystrosaurus emerging as the dominant survivor. For years, this narrative shaped how scientists imagined life's comeback after the extinction. But when paleontologists began exploring fossil sites in Tanzania and Zambia, they uncovered a very different story, one that challenged the old assumptions. In these northern basins, animal communities were strikingly unique. Distinct species of dicynodonts and gorgonopsians thrived, showing that the north was home to its own remarkable survivors. This evidence suggests that Pangea, the ancient supercontinent, was not a single uniform world. Instead, it was divided into biogeographic provinces, each with its own cast of characters and evolutionary stories. The impact of the extinction wasn't the same everywhere. Local environments, climate, and geography played a huge role in determining which species survived and how ecosystems rebuilt themselves. Even the recovery phase looked different. While Lystrosaurus dominated the Karoo, the northern regions saw a much more diverse resurgence, with many species making a comeback. These differences force us to rethink the idea of a single global narrative for the Great Dying. Instead, the story is one of complexity and regional variation. The extinction and recovery were not simple worldwide events, but intricate processes that played out differently across the globe, shaped by local conditions and unique evolutionary paths. By comparing fossils from the north and south, scientists are piecing together a far more nuanced and detailed map of life's collapse and resurgence after the Great Dying. The story is richer, more complex, and far more interesting than we ever imagined, full of surprises and new discoveries. With every new fossil unearthed in East Africa, the rules are being rewritten, and our understanding of the past grows deeper and more fascinating. The Tanzanian and Zambian fossils have transformed our view of Pangea. Instead of a uniform landscape, we now see a mosaic of distinct environments and animal communities. Physical or climatic barriers, mountains, rainfall gradients, may have separated these regions, shaping unique ecosystems. The Great Dying wasn't a single wave, it was a cascade, with local conditions dictating the outcome. These new fossils let us move beyond a one-size-fits-all story. Pangea was as diverse as any modern continent. By piecing together evidence from multiple basins, paleontologists are mapping a complex, dynamic world. This richer understanding is key to unraveling how and why it all fell apart. The Tanzanian and Zambian fossils are crucial puzzle pieces, testing and refining our theories about the Great Dying. Their differences from the Karoo force scientists to rethink old models. By dating rock layers, researchers can compare the timing of extinction across regions. Was it sudden or staggered? The pattern of survival is clearer. Generalists and burrowers, like some dicynodonts, made it through. Specialized predators did not. Recovery, too, was local and messy, not a global reboot. Each region's survivors shaped its unique path back to complexity. These fossils give us a front-row seat to evolution's comeback after catastrophe. The story is one of chaos, adaptation, and resilience. Digging up ancient bones in Africa isn't just about uncovering the distant past, it's a powerful warning and a vital lesson for our future. Each fossil unearthed is a message from a world that once faced unimaginable change and survived. The Great Dying, which wiped out most life on Earth, was triggered by runaway climate change, an event eerily similar to the environmental challenges we're grappling with today. The shifting weather patterns and extreme conditions we see now echo those ancient catastrophes. By studying these fossils, scientists can piece together which traits and behaviors helped certain species survive rapid upheaval, and which left others vulnerable to extinction. These ancient bones hold clues about adaptation, resilience, and the delicate balance of life. The lessons are urgent and sobering. Biodiversity loss and ecosystem collapse can happen far more quickly than we imagine. While recovery is slow, unpredictable, and sometimes incomplete, the scars of past extinctions linger for millions of years. The varied recovery patterns after the Great Dying show us the critical importance of maintaining diverse habitats. This diversity acts as nature's insurance policy, giving life more ways to adapt and bounce back from disaster. The Permian extinction teaches us that true resilience comes from having many refuges and options, not relying on a single solution. When environments change, it's the variety of safe havens that allows life to persist. These fossils are more than relics of a lost world, they're a guidebook for navigating our own environmental crisis. By comparing ancient records with today's data, we can better predict what lies ahead and how to prepare. They warn us of the stakes, but also offer hope. Life, even after the worst catastrophes, can endure, adapt, and eventually recover. The return of plants and animals to once barren lands is a testament to nature's resilience. As we face our own crossroads, the echoes from the Great Dying remind us what's at risk and what's possible if we act wisely. The choices we make now will shape the legacy we leave for future generations. The secrets of ancient Africa may hold the key to safeguarding the future of our planet, guiding us toward a more resilient and hopeful tomorrow.